Welcome to Educator.com. Today we're going to be covering the Pythagorean theorem. The Pythagorean theorem is a very important theorem, and this was discovered by the Greek mathematician Pythagoras. And since it has important applications it's based in geometry as well as algebra, we're going to start with a review of some terms in geometry. Okay, a right triangle is a triangle with a right angle at one vertex. So the vertex is where two of these lines come together. So right here would be a vertex. And in a right triangle, one vertex is a 90-degree angle. So this is a symbol for 90-degree angle. And if there is a right angle in a triangle, it's called a right triangle. The side opposite the right angle, so here's the right angle, this side here is called the hypotenuse. And it's important to remember that this is the longest side of the triangle. The other two sides are the legs. So this is one leg, and this is the other. The Pythagorean theorem says that if the legs of a right triangle have lengths of a and b, and the hypotenuse has a length of c, then a squared plus b squared equals c squared. And this formula has many important applications. So first, just sketching out what this triangle is going to look like and what this is saying. Here's my right angle. So the hypotenuse is going to be c. That is the side across from the right angle. So C equals the hypotenuse. And then I have one leg and the other leg. And I'm going to call these other two sides B and C. A and B. A and B. So A squared plus B squared equals C squared. That's the Pythagorean theorem. Just one other note, the angles are usually known by capital letters that correspond to the side across from the angle. So here's side A. It's across from this angle. This would be known as angle A with a capital A. This is side C, the hypotenuse. This right angle here is going to be capital C, and then up here, angle B. Let's do an example. So let's say that I have a right triangle. Draw another right triangle right here. And it has sides. Side A is 3, that's given. Side B is 4, and you are asked to find the hypotenuse. So you can do that using the Pythagorean theorem. You simply substitute in a squared, would be 3 squared, plus 4 squared equals c squared. To give 9 plus 16 equals c squared. Well, 9 plus 16 is 25. Solve this by taking the square root of both sides. C, or the hypotenuse, is 5. So if you have two sides, you can find the third side of a right triangle using the Pythagorean theorem. If you have a group of whole numbers, 3 whole numbers that satisfy the Pythagorean theorem, this is called a Pythagorean triple, or sometimes triplet. So a Pythagorean triple would be like 3, 4, and 5 in the last example, and that's the simplest one and probably the most widely used. So 3, 4, and 5 is a Pythagorean triple because it satisfies a squared plus b squared equals c squared. So this is a true equation, and it's using all 3 whole numbers. So there's a whole list of them. There's many of these. So let me just list down some of the more common ones. Okay. Now, the converse of the Pythagorean theorem says that suppose the two shorter sides of a triangle have lengths of A and B, and the longest side has length C. Okay, so we have a triangle. And this time, I haven't been told that I know that it's a right triangle. They're just saying, suppose that you have these two sides, and these are going to be, I'm going to say these are the two shorter, and this is the longer. If a squared plus b squared equals c squared, then this is a right triangle. Now, there is a subtle difference between this and what we talked about before. When we just talked about the Pythagorean theorem, we stated that if you're given a right triangle, so given that you have a right triangle, the sides have this relationship, a squared plus b squared equals c squared. This is different. Here we're stating we know the sides, but we don't know if it's a right triangle. So before, we knew it was a right triangle. We're trying to find the sides, or one of the sides. Now, we have the sides, but we don't know if it's a right triangle. So it's the other way around. It's the converse. So if whatever these lengths are, satisfy this equation, they have this relationship, then this is a right triangle. So if it turns out that whatever these lengths are fit this equation, the equation holds up, then I can say, yes, I have a right triangle. Right now, I don't know. But this is a way to determine if you have a right triangle or not. For example, let's say I am given that there is a triangle that has sides A equals 15, B equals 20, and C equals 25. And I want to know if it's a right triangle. Well, then all I need to do is go back and check out if it satisfies this relationship. So 15 squared plus 20 squared equals 25 squared. This is going to give me 225 plus 400 equals 625. And that is then 625 equals 625. So this does hold true. So yes, this is a right triangle. Okay? Now, let's apply to the Pythagorean theorem to some examples. In the first example, the legs of a right triangle have lengths of 7 and 24. Find the length of the hypotenuse. It's always helpful when geometry is involved to sketch out what you're given. So this is a right triangle, and the legs have lengths of 7. So I'll call this side A, and I'll call this side B. So A is 7, and I'm going to let B be 24. And I'm asked what C is. I don't know what C is. So using the Pythagorean theorem, A squared plus B squared equals C squared. Substituting 7 for A and 24 for B, you're going to end up with C squared. 7 times 7 is 49. 24 squared is actually 576. And this is going to give me C squared. So 49 plus 576 is 625 equals C squared. Now you need to take the square root of both sides, and that turns out to be 25. So C equals 25, or the hypotenuse equals 25. And you might have recognized this as a Pythagorean triple. If you did, then you would have known that what the hypotenuse is once you were given the legs. If not, working this out using the Pythagorean theorem works just as well. Okay, in the second example, the hypotenuse of a right triangle has a length of 10, and the triangle is isosceles. Find the length of the legs. All right, drawing out this situation. They're telling me I have a right triangle, and that the hypotenuse, C, is 10. Then I have two other sides, A and B. The other piece of information is that I have an isosceles triangle. And in an isosceles triangle, two sides have the same length. So what I'm given is the length of the hypotenuse and the fact that side A and side B are the same length. So let's define the length, whatever length this is, as x. So the length of A is going to be x, and since B is the same length, that length is also going to be x. Now, I'm asked to find what this length is, so really what I need to do is solve for x. Okay, Pythagorean theorem, a squared plus b squared equals c squared. Substitute in. I have x, a squared is x, so that's x squared, plus b squared, so that's, I said let b equal to x because we want these to be the same variable because they're the same length, equals c squared. Well, I know the hypotenuse, so I'm just going to put in 10. Simplify x squared plus x squared is 2x squared. 10 squared is 100. Okay. Divide 100 by 2. Divide both sides by 2, actually. So the 2 drops out from the left. It cancels out. And that's going to give me x squared equals 50. Take the square root of both sides to get x equals the square root of 50. And I can do some simplification on that because I have a perfect square. So the length of the legs is 5 root 2. So this side is 5 square root of 2, and this side is also 5 square root of 2. And I was able to solve that because I'm aware that an isosceles triangle has 2 sides that are the same length, and I was given the hypotenuse. So using the Pythagorean theorem, I went ahead and by having both these sides be the same, I was left with one equation with one variable, which I can solve. And I found that it's 5 square root of 2. That's the length of the legs. Okay. The hypotenuse of a right triangle has a length of 17, and the length of one leg is 8. Find the area of the triangle. This one's a little more complicated because we're not just asked to find the legs or the hypotenuse. They actually want me to find the area of the triangle. So first, just reviewing that the area of a triangle equals 1/2 base times height. Then I go on to draw the triangle, as usual. And it says it's a right triangle, and that the hypotenuse has a length of 17, and that's C. And I also know that one leg has a length of 8, and I'm not given what the other one is, and I need to find the area of the triangle. So the length of this side we'll say is 8, B is unknown, and recall that this is one side, this side will be, we'll say, the base, and then this is going to be the height. Okay. So I'm not going to get to my area formula quite yet. I can't until I find the length of this third side. So for that, I'm going to need the Pythagorean theorem. A squared plus b squared equals c squared. And I want to solve for b. Okay, so let's isolate b. And now we have b squared over here. Let's go ahead and substitute. B squared equals c squared. That's 17 squared minus a squared, which is going to be 8 squared. So that gives me 17 squared is 289 minus 64, or b squared is 225. Taking the square root of both sides, I'm going to get the square root of 225 is actually 15. Okay, now don't forget what they're asking me is to find the area of the triangle, so I'm not done yet, but I did find that b equals 15. Now that I know that b equals 15, I can go ahead and solve for the area. The area equals 1/2 the base times the height, so that's going to be 1/2 15 times 8. And that works out, 1/2 times 8 is 4, 4 times 15 is 60. And they don't give me units, but the area is 60 of whatever units that this is in. And again, it took a couple phases because I had to use the Pythagorean theorem to find this side and then go back and use the formula for the area of a triangle, 1/2 base times height. example, we're given that the longest side of a triangle has a length of 13 and the shortest side has a length of 5. Find the length of the third side so that the triangle is a right triangle. So what this is asking is to use the converse of the Pythagorean theorem. It's not giving me a right triangle. What it's saying is, here's the legs of the triangle. Here's the longest side. Here's another leg. Now, how do you make this into a right triangle? What would the third side have to be to satisfy the Pythagorean theorem so that we'd have a right triangle? All right, the longest side has a length of 13. So if this were to be a right triangle, if we wanted to turn it into a right triangle, the longest side would be over here, so that'd be the hypotenuse, or C. And the shortest side is a length of 5. So we'll say that that's side B. So I need to figure out side A such that it satisfies the Pythagorean theorem. So let's go ahead and isolate a squared, solve for a squared. And that equals c squared minus b squared. Substitute in. Hypotenuse would be 13, and this other side is 5 squared, so a squared equals 13 squared, which is actually 169, minus 25. Subtract 169 minus 25 is 144. Take the square root of both sides to get a equals 12. So in order for this triangle with a length of 13 for the longest leg and the shortest side having a length of 5, in order for this to be a right triangle, the third side would have to equal 12. If it did, then you'd have a 5, 12, 13 triangle, and that would be right. That would satisfy the Pythagorean theorem. Okay, today on Educator.com we covered the Pythagorean theorem, and I will see you next time when we talk about the distance formula.